We've got multiple camera angles now, which is very silly. So Google Meet and I guess Restream, which we're using for this, they now support extra cameras. And so I've wanted to try this for a little while because having like a little whiteboard while we're talking is something that is extremely helpful.
It is. It is. But do you have something in mind for today?
What about column mapping and deletion vectors? No, I'm actually. I'm so tired. I'm so tired of talking about column mapping and deletion vectors. I know that there's a lot of work that still has to be done there.
But I mean, I think there's one thing that I've been meaning to do for quite a while, and if you want to check out my PR, maybe even I could talk us through it. Because there's one thing we just need to think through once and clean that up. Yeah, and clean that up.
This
yes, one? This one. Actually, let me.
You need a rebase.
No, I did that. Let me just push some stuff. Yeah, let me push this and let me also
correct.
Yeah, let me also push this.
So while that comes up, oops. I wanted to. Oh gosh. Firefox is now very confused.
About?
I've confused Firefox. I'll have to maybe close my window and rejoin.
Who knows?
I'm not sure. I've screwed everything up. Uh-oh. I'll be right back.
All right.
If I can leave, you can check out, but you can never leave.
Huh?
Which also I think means I lost my Twitch. Just give me 1 second. Screwed everything up. I'll explain momentarily how I screwed everything up.
That's always great.
Sure, let's authorize it. Do. There we go. Okay. Unscrewed things up, but I had to restart Firefox. So you wanted to look at your pull requests for the DataFusion table provider.
Yeah, so I mean, one of the things is there's one thing or two things I wanted to do, or we could be doing. Let me just type type the PR message really quick, because otherwise this is going to be like a bumbling mess when I try to speak. Kind of what you're experiencing now, right?
Okay, you can focus. You don't need to entertain me and write your words. I could just sing. I could serenade you. I'm sure that would be very helpful for your focus.
All right.
Bruder Robert, schläfst du noch? Schläfst du noch? Hörst du nicht?
All right. Still need to force push it or what?
All right. So what Firefox does is they've got this sharing protection when you're screen sharing. And if you switch tabs, it says, hey, do you want to share this tab? Like, did you mean to do this, basically? And if you miss the little modal pop-up, at least for me in the Firefox related, if you miss it, the whole window gets screwed up. Because it's like, oh, well, you didn't want to share it, so I'm going to lock that window. And it basically doesn't redraw, doesn't anything. It's really, really annoying. But anyways, you force push?
I pushed it. Well, I didn't need to force push. I just needed to rebase really quick, and that was painless.
Oh, good. Yeah, there was a change that I had brought in that was just some of the log store refactoring stuff that Jan had asked about over the weekend. Okay.
Yeah, so let me... The thing that we maybe should look at, and I think it's easier probably if you can check out this code.
Warum?
Because I don't know that the diff is as meaningful as looking at the whole implementation.
Oh, okay. That's always fun. 349 or 3649? 349. Oops. All right. Not possible to fast forward. That means I've got some changes here that I need. I'm just going to blow away this local branch. Feet, table provider. Recreate the branch. All in core?
Yes, now go to Delta DataFusion, I think.
One moment. What we're going to do is start the compiling fun in another window. Delta DataFusion. Engine?
Yeah, so no, table provider.
Oh.
Next. And then let's just start with mod, and then we'll just go through.
It's usually where I will begin.
Go through what we do. So yeah, you can actually, we can look at the snapshot there. If we go to the scan method, and this is already kind of one important difference, but ultimately it shows a lot of what we did deliberately. So the first thing is we create this kernel scan, and this is what we'll be looking into more, or we invoke this kernel scan method. And then, well, we just get an engine from the session, and we do the kernel metadata replay, like when we get the stream, right? The scan metadata, this will give us kind of the stream over the file actions. Yeah. And then we
let's talk about what's going on here. Kernel scan is on snapshot, correct?
Yes.
Okay, so that's coming from snapshot. DataFusion engine. This is I guess this is our code. Looks like.
Yes.
No, I didn't mean to jump to that, but mouse clicking apparently jumps. Scan metadata. This is a default engine function, or is this part of the engine API?
Well, this is it's not engine. So this is the scan object from kernel, or this mimics the scan object from kernel. So we have our own scan object, and we can look at that really quick if you just go into that method. So we have our own scan object that exposes this function that actually just wraps in many ways the kernel scan, but it abstracts away the transformation between iterators and streams. Right, so this is kind of a scan how we would like it to look when we look at kernel. It deliberately doesn't try to add much functionality other than translating this into, let's say, async, stream, Rust idiomatic APIs, if that makes any sense.
It makes sense to me. Part of the reason why I'm asking is I've been, since this weekend when I was doing some profiling work that we were talking about, I've been thinking about moving Delta RS off of the default engine. But we can talk about that later.
I mean, we're already using a DataFusion engine here, which is kind of a first step of the default engine. And then we could also build a custom arrow engine, of course. But yeah, this is anyway.
Withhold my commentary.
And then you see we go into this execution plan method. But just for fun, let's look at the eager snapshot, what that same method, the same scan method looks like there. Yeah, that is it. So we invoke kind of the same kernel scan method on the inner snapshot. We get the same engine, but here we use this scan metadata from API, where we feed into. Actually, I actually tried that. Yeah, that elsewhere we switch to this pattern, but here. You run into some lifetime issues. But here the important part is we use this scan metadata from API, which allows us to recycle our materialized state. Ultimately, though, what we're consuming after this always kind of looks the same. And this idea we apply in many places, right? So we just feed it into a stream, and even though we have it in memory, we expose stuff on the stream so that it's a painless switch to not materializing anything and moving to full incremental processing.
This is right? The insert into is calling the snapshot into, which I think is good. How come this, like, why doesn't this call self snapshot scan?
Well, this is because. So the self snapshot scan is self snapshot execution plan, but the stream of file actions from kernel, we either, if we have some files in memory, we save that work, right? So this files method, this will error out if the eager snapshot was initialized without requiring files, right? But if we have something in memory, we'll use that and replay from there rather than doing all the I/O work. So the way this stream thing gets initialized, like in the else branch, this is then 100% equivalent to what we do on snapshot. But in the sort of if branch, we use a different approach. And here we're actually now in the most interesting part where we need to think about a little bit what's happening, because that's what I've been working on. Kind of. Well, not kind of. But
we kind of need to think about it, or you've kind of been working on it?
Well, we kind of need to think about and then kind of fix it.
All right. Very non-committal to our plan of action here.
Let me explain what's going on. So this issue came up, luckily, from a unit test, and it's the situation is we have a count query, count star, with a predicate, but this predicate is on a partition value. Why is that important? So in DataFusion asks, before planning the scan, which predicates do you support, pushdown wise, right? And you get this list of expressions, and for every expression, you need to return either exact, inexact, or unsupported.
Oh yeah, I've seen that.
And this is what this get pushdown filters. I didn't write this function, we had this before, but this get pushdown filters returns exactly that, right? For each predicate we pass in there, it gives us exact or inexact. Actually, we seem to never say unsupported. But what happens after this is important. So for a count query, we need nothing in terms of data. We just need the right number of rows actually on an empty record batch, right? But when we invoke the kernel scan, kernel internally doesn't differentiate between this is something I can exactly evaluate because it's a predicate purely on a partition column, or this is a predicate where engine needs to do some work. So essentially, it always says if a column is in the predicate, it should also be in the projection. Whereas DataFusion says, here's a projection I want from you. You said you can be exact on this predicate, so you figure it out. Make sure that the data you return is kind of complies with that predicate. But it doesn't want to see this column because we don't need it in the final result, and we already said we can be exact on filtering for this column. So what this means is we set up the kernel scan, and this is what's happening here, right? So we get the pushdowns, we get the projection, and then we check essentially what's not within the projection, but is referenced in a predicate, right? And here I wrote this comment, right? I mean, if a case exists where a column is not part of the projection, but used in a predicate, but also not part of an exact predicate, this will blow up, but it should blow up because that situation should actually never arise, because DataFusion should be aware that we can't filter exactly on it, right? So here, it just made it more complex for us to also raise an error. So my hope is we'll just kind of hope that DataFusion does the right thing. If it doesn't, it will still blow up, but on the DataFusion side, maybe with a less expressive error in a sense of, oh, I don't have this column, right? I can't evaluate anything. But in principle, if DataFusion is not broken, and that would be a bug in DataFusion if that happened, by the way, right? Because DataFusion needs those columns. So that's why I opted for not raising, but just kind of swallowing the fact that we kind of know something's off, but still. And then
you can always.
You still need to. Okay, yeah. So then we just append the projection with everything, with all the columns we were missing. And right now, and this is where stuff is blowing up. So I just increase this project away count, kind of just counting how many columns do we need to cut off, because we always append to the end, right? So just saying we added so many, Now let's remove the rest. So that's what's happening there. And here, when we build the execution plan, yeah.
What is this?
This is
This transforms.
Yeah, so this scan file stream, we can go into the scan file stream really quick and look what's happening there.
Is it gonna make me happy or not happy?
I don't know. Hopefully it'll make you happy.
Hopefully.
So the scan file stream wraps the stream. And here you see we poll next, we get a record batch. We visit the record batch, right? So the visit scan file function is further below. But this is where we're doing sort of the visiting, and kernel hands us useful additional information. Here it does get a little more interesting, because loading stuff here where we're dealing with the sync async bridge again, because we now want to load deletion vectors that may be defined on this, right? So yeah, we check if there is a deletion vector. If there is one, we generate this load deletion vector task and spawn it on a runtime like a collector we carry around in the context in this stream. So just
the reason why I have the exasperated exhale, and this is not it's not about you or this code. It's this the pull next combined with a blocking send or a spawn blocking means that whatever asynchronous anything is happening on either side of this is now being consolidated into a single task, into a single thread, and there's zero parallelism.
It is.
And we have this in a lot of places. And
I mean, here
I'm
we
racking my brain
just,
with ways to get rid of it.
But I mean, here we spawn this, right? So I mean, at least this function shouldn't block. Like the poll next shouldn't block on any of this.
The pull next will 100% block on this. The only way to not block on this is if you spawn something and you return none, so that whatever is hitting that pull next can continue to do something.
But I mean, I think this should be the case here now, right? So, I mean, you see the blocking send is inside this closure, and we spawn this closure.
Yeah.
But within the poll next, none of this work should happen. This should be a separate blocking task that Tokyo spawns, but we're not looking for any responses here from this.
The caller of this is blocked. And so whatever task is, like, it's
I mean, maybe
being in a poll next doesn't make it asynchronous or parallelizable, I should say, by default. Like the only way to, like, a poll, what's the other poll pending? Like you've got to be able to get out of a, why is that highlight there? Go away, highlight. You've got to be able to get out of this loop with a poll pending in order for Tokyo to do that context switch.
I mean, but just for me to understand, right? So I mean, we have like we have this channel here, yada yada yada, right? So we create line 112. We create a sender. And then we create a task, right? So in line 114 to 118, we do nothing. We just create something that you can call, but it's not doing anything yet. And then we say, please call this function on this separate join set kind of spawn blocking thingy. And I think from that point on, we don't need to await any result of this. We just say here, this function is the task. You go ahead, invoke it. It's a blocking task.
Go away.
Because in get selection vector, this is where we do async work. So line 115. But I think here we shouldn't expose it. Actually, is then if you go to the mod again. Yeah, go to the execution plan function where we were earlier.
Hold on 1 second. So spawn blocking gives you a join handle. You join. I'm just reading the spawn. So the blocking send I'm less concerned about because that means the channel has to be able to like do something with it. Inside of a closure, in theory, that is gonna be fine.
I mean, here, just to be clear, the spawn blocking function is not Tokyo spawn blocking or anything.
Oh, it's not? What is it?
No, it's not. This is something I stole from DataFusion. If you go to, just go to that function. This will just spawn it on this sort of inner join set. It's like a stream builder thingy where you can spawn multiple tasks and then later on consume them as a stream. Like you see the build function.
This is, where did I go? We're in execution plan. We're looking at.
Yeah, 281. This is where we then build a stream from this. And then below, the try collect below, right. This is where I hope the work happens, kind of.
So let me go to, this is where I wanted to come back into. So where does this load DV then get collected?
Where you were before. If we go to the...
But it has to come out of this, right?
So we do the spawn blocking. There's this DV stream thingy, right?
Yeah.
This is kind of the DataFusion construct that I just copied. And if you go to stream, it should probably be, I think it's kernel, source kernel stream. Yeah, snapshot stream, I guess. It's not the best place. But this is where we have the spawn blocking, yada, 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 yada. Yeah, right. So here we just send it. This is what actually creates the stream from it. And now if we go back to the table provider next mod,
Hold on. I have to understand how the code works before I depart. All right. Next mod.
So there. Yeah. So there, 282.
Yeah, this is where you think you're picking it up.
Yeah, and this is where, I mean, we ideally have some await points, but this is where we actually need all the blocking tasks to eventually kind of finish. So we have all the deletion vectors.
So it's not a Tokyo spawn blocking. So it's what? Where is that scannable file stream thing again? Or scan file stream? Where does that live?
That's on the
stream. Okay. That's also in stream.
You can ignore the dispatcher because that's just for tracing.
Join set. Join set's a Tokyo thing, right?
Yes.
Yeah. Let's go look at join set. Ah. So when we get a join set collection of tasks spawn on a runtime, the coefficient of some or all the tasks. With a join set, I mean, with the way that async await works, with things being sort of like lazily evaluated, what tells the join set to go? Or is that like tasks in the join set should start executing?
Well, I mean, once we submit them, that's when Tokyo has the freedom to drive them forward. And then the question is, when do we start polling it? Which is in the mod where we do the, yeah. So yeah, I mean, our polling is when we do the try collect in the execution plan method.
So what's not clear from the Tokyo documentation that we pulled over is this is a little unclear to me, that we spawn the blocking code on blocking packpool and store it in this join set. So it's not clear to me whether in this case we're going to get, I think it's going to work incrementally.
You mean whether or not the work will, whether it'll try to drive all of them concurrently, sort of, right? I mean, here, I mean, it would obviously be great if the work got done, but we still need it to be sequential for consumption. well, no, we need the results in order. That's kind of the more clear terminology, I think. Well, actually, we don't, but they're better in order because we read the files in that order and we need the deletion vectors kind of in that order. But yeah.
Well, I guess, so let's just say whatever the blocking thread pool is, let's just say that's, num CPUs, right? So on the machine that I've got, that's 8. If this is starting 8 tasks at the same time, and then we collect those results, that would be parallel. If this is spawning 8 tasks and then executing them sequentially, then that would be quite inefficient.
I mean, to be honest, I don't know.
Me neither.
But
that's why we're looking.
I think this is something. So let me maybe, before we kind of go back to the original problem, one thing I wanted to do here next is write some tests.
Yes. I'm always in support of writing tests.
So we should be able to kind of just work with the low level table provider APIs and read our example tables, kind of the tables. And I felt like we may need to write a little bit of boilerplate to validate the results. I don't know what it is. Well,
this has me a little concerned based on the work that we just did, because this is going to take a relative path.
No, but so this is one important pattern that we do in a lot of places. If you look at what this method returns, right? So the file URL within the scan replay stream, we assure is always a URL, like a full URL. We do take the path, but we create this sort of as a tuple of the object store URL, which is kind of the finest level of granularity we have to distinguish object stores on the DataFusion level. And then below 317 and below files by store, we group the partition files by the object store they require, and then actually within the getReadPlan method, if you look at that method, especially at the return in the end, but we create a dedicated execution plan for every store, because the DataFusion Parquet plans, they can only deal with one single store. And then if we find that we have multiples, we wrap it in a union. 406, yeah.
That's cute. I like that little snippet.
And by the way, and I'm not saying that this is consistently applied, but you see the plans remove. So in earlier days, when I was less conscious about memory, I may have done, oh, this is an arc, who cares? Let's do a, I don't know, plans 0 clone. Now I'm like, well, no, we already allocated this. We don't need it anymore.
Growth, buddy. So DVs are loaded here, deletion vectors. Where are those getting applied? Did I miss that?
No, that's so what happens after, and this is kind of also where our problem now reappears. So we create all those Parquet plans, and then we create this, or we create one single Parquet plan that may be a union, all good. So if you go down again, Yud, yeah.
And get read plan?
Yeah, I mean, we did get replan. There is a bunch of stuff we can do better in here. So this I expect this function in half a year to be, I don't know, 300 lines. But why? Because you can do a lot with DataFusion Parquet plans. But here, this is kind of the bare
Is this
minimum.
where we would be pulling in the deletion vectors if we were to push it down to the reads?
Yes, if we were to push deletion vectors into the reads, this is where we would need them. Actually, line 389 is kind of a method I previously pulled out of like the compute Parquet access plans. This is something that Spice AI did. But yeah, this method doesn't exist here, I believe. But it's a complex method that does a bunch of fancy stuff. But I was like, yeah, let's get it to work, and then let's make it better.
I mean, if we had something that where was that? Way up here. So when we get our DVs, if we had something that turns for each of these Parquet files that are affected by a deletion vector, just turn that into a row filter. Can't we just pass like shouldn't this be a simple computation to just transform that to row filter for the Parquet read?
I'm not sure. So I mean, there's a little bit of complexity because we need to spread those across record batches, right? So you do need to look into what are my row groups, because what you do is you do the filtering based on a row group level. So we need to go through the row groups and then slice the deletion vector into chunks for each row group. And we also may need to extend the deletion vector, because I think kind of it stops at some point, and then you need to assume the rest is true, right? The rest is selected up until where we need this. But I mean, ultimately, all of this can be done, but I think it's the wrong time. I think we need it to work first, because I need to understand how this works, how this affects row IDs and things like this.
I mean, these are basically row filters. Like, we don't have to care about row groups, but row filters is basically what. Like, the reason I could be oversimplifying this, but the part of the reason why the Parquet pushdown of deletion vectors to me feels like the right thing to do instead of worrying about deletion vectors in any other way, shape, or form is it seems like if we just never see the data, it never gets loaded anywhere, then everything up the stack becomes much simpler, because you're not worrying about applying deletion vectors on the DataFusion level or anything, above that, because the data just never was considered. Like row IDs or any of the other higher level functionality doesn't matter, because that data never existed when it came out of the Parquet read.
I mean, at some point, for some row IDs, we need to know how many rows were loaded, because it's kind of logical offsets, right? You have this base row ID, and then you need to compute based on this row, blah, 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 blah. I don't know. I think we should look into this. I just think not now. Because it's another potential source for errors.
Well, row IDs is something that's like a way advanced feature that I've not seen anybody using. Deletion vectors was forced upon a lot of users that are now like affected by the lack of deletion vector support.
But I don't think applying deletion vectors is a problem, right? I mean, we kind of have the right place to do this right now. I don't know that it's simpler to push it into the Parquet read than it is to, because this create access plan function, and I have that elsewhere, actually applies the deletion vectors, right? So I could surface that code again, and I'm planning on, but I was hoping to get kind of the other stuff I felt this approach is simpler for now rather than pushing it into the Parquet read, because we also still need to do the translation of predicates between physical and logical to push this into the read, stuff like this. Like we need some manual cleanup of the
What do predicates have to do with it? If they're deletion vector, I mean, it's on a file by file basis. The data just
but I mean, still, we also may want to push predicates into the read, right? But then we need to make sure that we apply the deletion vectors correctly also when we combine them with predicates and all of this goodness. Because predicates may also skip row groups, right? And then we need to do the right skipping on the deletion vectors based on how many offsets we have. It's complex is all I'm saying. So that's why I wanted to just not worry about this. Apply it where it's much easier for us to apply, and then optimize later.
I am a little concerned because what I feel like you were saying is that we boil a lot of the ocean, not the whole ocean, but we boil a sizable chunk of the ocean and do data fusion for all the things. And by doing data fusion for all the things, it will be so much simpler, easier, like so much simpler and easier to do all of these other things that we've been wanting to get done.
Let's just look at the other code. It's not a lot of code. I mean, right now we just loaded a Boolean vector, and then if you go into the Delta scan exec, yeah, there is the map. Like the project batch or something, the method is called, I don't
know. There's filter, statistics.
No, that's this not in the execution plan. Gather filters for pushdown is another good one, by the way. And oh, sorry, the Delta scan stream. We need to, the batch project. This one is the interesting one, right? So here we get the actual batch that was read from a file. We read back the file ID with the file ID, and here we special case if we have 0 columns, so an empty projection, we just return, we don't care. If not, we get the file ID, we get the transforms that we stored for this file, right? We extracted those, and applying the deletion vector is not being applied here yet, right? But ultimately, it's the same logic as with the transforms. We get the selection vector and do a filter record batch here. That's it. And yeah, we already track the deletion vectors. We just don't apply them yet. But again, that's, I don't know, 10 more lines of code.
It's just, well, if it's just that simple, Robert.
Well, I mean, right now I'm dealing with a different issue around projections and expressions, which I wanted to
read Parquet files in bool. I guess when I've been thinking about deletion vectors in particular, I've been looking at this code in kernel, which is where we have the read Parquet. And all things given equal, like let's say somebody, we want to push down deletion vectors to the actual read. Like that's where the actual performance, that's the whole point of deletion vectors in the protocol, was to push down all the way to the IO read.
Well, I mean, I would say it can also make your commits much faster, right? You just don't need to rewrite the data, and that's where you gain some performance. Yeah, but yes, obviously, if you push it down with the Parquet read, that also helps a lot. And just to be clear, I'm not saying we shouldn't be doing this. I'm just saying let's get the feature supported first and then optimize away downstream once we're confident that it works.
I think the disagreement that I have with that approach is I think that is twice the work to get it to work in the inefficient way and then to make it work the efficient way.
Well, I mean, all I can say is while row IDs may not be the most popular feature, we still should not. I don't understand it well enough to say we can support them easily afterwards. And they should have some code here in kernel that does this probably in some way.
Why were these added?
But I think the default generated, that's kind of the problem case. Because the generated row IDs...
Oh, this one. I see.
Yeah, is we take metadata from the add action and then we kind of count from there. And there we need to know sort of the exact offset of a specific row within the Parquet file, accounting for row group skipping and all of this kind of stuff.
I think knowing your employer and knowing some of the lineage functionality that your employer sells, I can see why this is interesting.
CDC, I think, also can be built more efficiently on top of this.
So what I'm not seeing is that row IDs are row IDs represent row indexes. Am I missing that here?
I think the base row ID, right? So you have the base row ID. Yeah, so row IDs for data files are calculated by adding the base row ID of the file in which a row is contained to the physical position index of the row within the file. So we need to know the absolute kind of immutable index of a row within the file. And I don't know where to get this from yet and how this sort of gets applied in the Parquet read, but we can't just count, because if we have predicates that do row group skipping, and if we have deletion vectors that may actually just filter individual rows from within a row group, we need some other way of housekeeping what the original index within the file was. And I know there's ways around this. I just don't know what they are and didn't want to dive so deep into it and rather get the features out.
There's no mention of how deletion vectors might be tied into this. That is extremely annoying. Where's deletion vectors? Up here. Where was row tracking? Okay. Bring it up. You said there's row ID stuff in kernel's default engine right now?
I never looked at it, but there should be at least a lot of row ID work landed. Yeah, and there is in the transformation.
Would that be a write level concern?
If you materialize them. If they're not materialized, then you need to put them in as you read it.
If you materialize them, you have to put them in as you read it. I saw a mention of I see. This is going to be an annoying feature to support.
I mean, one thing that is good about this, and there is more stuff, right? So we also need to support like schema evolution, but we want to support this on a within a struct sort of level, right? And luckily also DataFusion. So right now we have this schema adapter. DataFusion changed the approach how to do this, and now you should use like a physical expression factory or whatever. So I'm learning more and more what the latest state of the DataFusion APIs is, and I'm 100% planning on, actually this is sort of my Christmas gift to myself to dive a little bit deeper into this when I'm undisturbed by working and much less kind of daytime commitments. But this is what makes kind of how do we do schema evolution and predicate pushdown and deletion vector pushdown, and also while still supporting row IDs and stuff like this. So building up these Parquet read plans is going to be, right now it's a fairly small chunk, but I expect this to be the vast majority of the code later on.
So I think
especially keep in mind that we always need to assume Parquet reads are in the physical world, because there are some interesting functions.
You mean like pre-column mapping? That's or pre-logical structure.
Yes, exactly. Yeah. Because there are some interesting functions on the execution plans that deal with optimizations that DataFusion does during physical execution after logical planning, which is so-called gather pushdown filters, or gather filters for pushdown, which when you do like merges, joins, what have you, somehow this gets activated. But here, damn it, I forgot his name. Like they're using Delta RS, did some great contributions. A lot of the merge implementation, for instance.
I can't recall.
Anyway, he pointed this optimization out to me and then had like an example when he implemented, if you do a git blame and see who implemented gather pushdown filters on the current table providers. Cole, McKenzie, Cole.
Oh, Cole. Yeah, I remember Cole.
Yeah. So he pointed this out, and also on the PR showed like what a tremendous difference this makes to support this function, gather filters for pushdown, it's on the execution plan, so it's within the scan.rs. But there we're square into the physical world and need to translate physical predicates sort of as runtime, yada, yada, yada. But it makes a huge difference in the performance if we can support this functionality. I guess what I'm saying is this is a gift that keeps on giving, the table provider.
I believe in the approach. Take my concerns in no way as a stop going this direction.
Yes.
Sort of bit of feedback, right? I believe that the approach is going to bear fruit. The concerns that I have are, I don't know if people smart enough to use DataFusion to its best exist in the Delta Lake project. Like, the DataFusion folks are extremely talented. I am not at their level. I barely understand half the shit that they do in DataFusion. And so it is a little bit black boxy to me, to where I am concerned that, there's a black box where we say DataFusion makes fast, and we're trying to route everything into that black box. So I'm glad you will understand it. That will make one of us.
Hopefully soon. We'll see.
But the other concern that I have is, like, there's a maintainability part of that angle. The other concern that I have is Delta Kernel has some galaxy brain level abstractions that exist that may or may not be good ideas. I will hold off judgment at the moment. DataFusion has galaxy brain ideas on how things should be optimized. And what you are volunteering to be is the bridge between
to try to include
two very differently motivated environments. And so it's just like, again, like, don't stop going. Like, I do think that this is worthwhile investment. But it puts us in a really difficult position to sort of be between two fairly different worldviews on how to structure things and us to translate between them.
So I do agree. I haven't given up hope that we'll see an async kernel one day.
Buddy, I'm going to be building that. I'm so angry at the lousy performance of kernel that literally this morning before we started working, like, I'm trying to figure out where the boundaries are, because async kernel is something that if it doesn't get built in the next couple of weeks, I will probably be building it.
Let's I think let's talk with Michelle and Nishith. But yeah, other people share the sentiment that in Rust you want async support, and while it may be a challenge at the FFI boundary, there must be other ways than saying Rust, you suffer.
I think even the FFI boundary, like, I think there are design decisions made in kernel that are antithetical to high performance.
I can't judge this. I have too little knowledge about FFI. In the end, though,
it's not about FFI. It's fundamentally this view that we can take, that we can abstract away everything. If we abstract away everything, then you'll be able to get the optimal, most great performance, whatever. I haven't seen that play out anywhere. And so for Delta S, I mean, we'll see how the experimentation goes. Like, we need an async kernel engine, period. And I think in order to support that, kernel is going to have some APIs that change.
I do think we'll get that, right? I mean, this is why this shim exists that says this is what we'd like the scan API, for instance, to look like, right? Don't give us an... I mean, in many cases...
You mean the shim that you built?
Yes. But I mean, it's not a shim in terms of it mimics the performance or the execution runtime characteristics, but it's something where like, okay, all we really want is whenever we do async work, make it either async or give us a stream, right?
So,
depending on
okay.
what it is.
So this is where I think kernel has tainted our view of things. A lot of the stream abstractions, we're looking for kind of materialized data, loaded data to be delivered on a stream. And the only way that we get good performance is if behind that stream shim, if there's actual parallelism happening that's allowing IO operations to be run in parallel, not concurrently. Right now we have concurrency, but we don't have parallelism. And so in some cases, this is where I'm not sure if like we actually need a stream or not. Or like we need futures basically.
I mean, the one thing that I can say to that is, and this is not coming from sort of knowledge, just empirical evidence, but as of today, I think DataFusion still is, for some of the ClickBench cases, the fastest single node engine with Parquet reads.
Mm-hmm.
Right? So, and I think in order for this to be true, there must be actual parallelism. I exhaust all my cores kind of parallelism exists within the DataFusion execution model.
In DataFusion.
And now the next thing is DataFusion does everything on streams, right? Maybe, I mean, there is sort of this setting sometimes, I don't know, with, you can tell Rust sometimes, I forgot what it's called, buffered, right? So just buffer execution for, I don't know, have like the next 10, blah, blah, blah. Maybe we need some of this, but I think in principle, streams in and of itself are not limiting the option to be parallel in terms of doing the work.
It depends what's in the stream. And this is why I was looking at that code earlier. Like if the stream is giving you pull next on blocking operations, and I can't speak to that code that we were just looking at well enough to say whether it's actually blocking or it's just concurrent in some way. But if
how about this? How about this? Because there's two things I want to do. Well, there's many things I want to do. One is get that implementation to a point where it's also tested.
Snapshot next.
Yes, snapshot next, right? So right now I need to solve this one issue that's still failing tests, but then I also want to merge this with new tests before integrating it. But one thing that we've been doing very successfully in Delta RS is simply apply high-level tests for everything and don't kind of go deep into, for this, I want to test directly the table provider.
Ian's idea about the Python layer, I think, is a really good one there. Because if you just, Ian's idea about Python, like I think you could probably pull this table provider for straight into the Python operations, and you'd get a lot of that like acceptance level testing kind of for free.
But I want the low level testing, and I also need to write a blog about this, and we could work on this together. And actually, if we just execute the low level tests with the proper runtime, we should see parallelism happening there or not, right? I mean, this is sort of a fairly low level thing, and we still might mess it up further down the stack, right? But in principle there, we should be able to prove, can this thing do parallelism the way we want or not without, I mean, there is a bunch of stuff happening, don't get me wrong, but we also eliminate a lot of the downstream sources where we might make things worse, right? And if we're not able to achieve true parallelism at that level, well, we're not going to be able to anywhere downstream.
Can this open a table yet? Can I just use this table provider to open a table?
Yes.
If you give me a code snippet,
I can write some tests.
I don't need you to write test. I just give me the code snippet, and I'll use my big giant transaction log table that I do my performance testing with, and I'll open it up and we can just gut check the parallelism right now. I mean, not literally right now because I got a meeting coming up, but
me too. But I'll provide a code snippet and then let's test this low level thing and see what it does.
So for this pull request, what do you want to add more tests before you pull it out of draft and say it's ready to?
I mean, I have, so my local version actually rewrites a bunch more stuff that shouldn't be part of this PR.
Okay.
But I run all the DataFusion integration tests and stuff like this, and some of them are still failing. So I want to do some fixing there, but a lot of them are passing, right? It reads a lot of tables. This count table that I mentioned earlier is
growth mindset right there.
Like
it fails tests, but it's also passing tests. So
yes.
Always look on the bright side.
Yeah. Well, I mean, it's not completely useless. There are code paths that execute useful code.
I mean, it's high praise for the work that you've been doing. It's not completely useless. Good work.
Yay.
So next week, I don't think I'm going to have the time to do this. So I think the next time we're going to be able to hang is going to be probably in January.
Yeah.
Like we'll be doing stuff, obviously, because you're going to be data fusioning. You're going to open up the Pandora's box of data fusion and see the Ark of the Covenant of data fusion.
Yes.
It's gonna. We'll see how it goes. I'm gonna see about some async and kernel and kernel engine.
Also beautiful. Also, feel free to go deep. Yeah, fun.
I've now heard this from multiple people. The performance of Delta RS after 0.26 is, I will diplomatically say, it is insufficient. And I don't think, like, there's the cat batches thing that we had looked at. I don't think it's a lot of the stuff that we're doing in Delta RS necessarily. I think there's a fundamental performance challenge with the default engine. And I want to prove myself right or prove myself wrong by implementing a different engine. So
yeah, I mean, I feel like we're collecting more and more signals. Also with kind of the new, one thing I have also as a holiday project is to create like a big TCP DS kind of chunk, and get deeper into tracing some of this and seeing some of those profiles, right? But we gather more and more places where we can run significant workloads. Because that's kind of, I think, the big problem. If you have small stuff, none of this really matters and disappears in, I don't know, day-to-day GitHub jitter or whatever.
Yeah.
You need to put actual load on the system to get like a proper signal on performance.
That was a point I was making to some colleagues yesterday, is you kind of have to have, like, the combination of performance profiling has to go with load testing typically, and you have to have some way to generate that load. And that is a gap that we have right now, is we don't have a lot of good synthetic load outside of stuff that I have like proprietary tables to do this.
And I mean, we're also limited by the CI machines. We don't have any memory to spare.
Those freaking things. Yes, that is correct.
Yes.
We are limited by those.
I mean, one thing we could probably do is just build them and then copy the artifact on a fresh machine where we don't have to build, or nuke everything else, I don't know, and then copy more data onto it. I don't know if that'll help. But yeah, so next meetings are coming up. It was great fun for me. I hope this.
I'm excited for you. I think you're gonna have fun. I think
that is true.
So let's see. I mean, opportunistically, if I've got some time for us to do some pairing over the holiday break, then I will let you know in Slack. I think we should talk on Thursday with the Delta Kernel folks about row IDs and deletion vectors as a like, how do these things actually play together, if they do at all? And yeah, I don't know. This has been fun. Thank you for taking me through some of the code. I have more questions than I started with, but that's okay. I'm okay with that.
Excellent.
That's not a bad thing.
Yeah, thanks for bearing with us, and